Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be presenting tonight will be I replace the battery charger of my cordless drill here. The cordless cordless drill is actually rated 12 volt 1 ampere. When I plug in this one, the LED is not lighted. I would like to troubleshoot this one, but unluckily there are some small ICs at the back, and there are no burned marks. But when I plug in this 220 volts, the voltage at the terminal is actually zero. And one thing more, the LED is dead. The LED indicator is dead. This one. So to troubleshoot this one, it should be another thing. So what I did, guys, is that I got a terminal like this, similar to this one. This terminal here, the one at the middle is actually the positive, and the side is actually the negative, and that's the one here. So I got an equivalent of this one, and I made it as this one here. Okay, and I checked that the middle thing is actually the positive, and the side thing is actually the negative. So I connected a black to the negative, and this white thing here to the positive. So meaning to say, if I charge this one, I should inject the positive terminal here, or I should connect the positive terminal here, and the black will be the negative terminal. And luckily also, I got an assembled voltage regulator. This is a very powerful one. I actually I bring out one of the terminals such that I could vary the voltage at the output here. I could vary. Okay. For now, since I will be charging this as 12 volt 1 ampere, I set the voltage here to 12 volts. Okay. It's not 12 volts. It should be around 12.5, 12.7. So when it draws current, it drops to 12 volts. So it will not overcharge the battery. So I set this one to around 12.7. And I plug it in. The LED terminal is alive. If we try to measure the voltage here, it's around 12.7. And I connected already the battery to the terminal of, I connected the, what I call this, charge terminal to the battery. It's here. Okay. I plug it in. And I connected in series an ammeter with the positive terminal. So I should know that this battery here is charging. If this battery here is not charging, it will not draw current. But as of now, I set my multitester to ampere current. It's in the 10 ampere range. This is the ground. This is the plus terminal. So I connected this ammeter here in series with the positive line. And what comes out is actually 0.441 amperes. 0.441 amperes. So meaning to say, by using my assembled power supply, in which the output is variable, I set this one to 12.7, so I will not overcharge this one. A while ago, I measured this one. This is 12.7 volts. And right now, I plug in the battery, and I monitor the current consumption of the battery being charged. It's around, a while ago, that was 0.5 something. It is going down, meaning to say, as soon as the current goes to zero, this is now fully charged. At least we know that this battery is charging because it got a current consumption. A while ago, this was 0.5 amperes and it is now 0.431. Okay, and I try to fill it. It's not hot because the worst thing that you could do with the battery if you are charging is that it should be the reverse polarity. It might explode. Okay, but I check it because a while ago, the original terminal, the middle thing is plus and the side thing is minus. And I do the same for the replacement, what you call this connector here. This one here is same as this one. So the polarity of this one, I should follow the polarity of this one such that, I will not be exploding the battery. So the middle thing is actually the plus, the side is actually minus. That's what I did here. I made the soldering a while ago. I place an insulation, a heat shrink tubing, so the plus and minus will not touch each other, so we avoid short circuit. And right now, the battery is charging. Okay, the current consumption is 0.412 amperes. Maybe I will charge this one for around, I will come back at 30 minutes and let's try to see what will be the voltage output of this one. Okay, that's it guys. That's how I remedied a replacement for my battery charger in which it was defective because there are some small ICs here. I can even see the serial number. And I think the best way to troubleshoot this one is to reheat the solders, the terminal solders. If it comes back to life, that's it. But just in case after reheating the solders and it doesn't come back to life, maybe some of the ICs is dead. And if this IC is dead, of course, this battery charge is dead. Like this one here. Okay, so with regards to my experience, if there is a dead power source and by inspection you could not see a burnt mark, the possible thing is that there might be some loose connections on this other connection. So later on, okay, I might troubleshoot this one. I will try to, reheat some solder terminals over here. And if it doesn't go back to life, of course, I will just throw this one. The components on the other side are not too many. This is the transformer here. Electrolytic capacitor. This is a high frequency capacitor. It's still electrolytic. But on the other side, it's a complicated thing. Because the other side, it got so many surface mount technology parts in which the troubleshooting is different from the normal thing, Okay? So just in case one of the surface mount technologies here or parts is dead, or it could be an open circuit thing inside in which we could not see it, we cannot do anything about it. The best way to troubleshoot this is just throw this one and make the replacement. Like what I did, I made the replacement. Like right now, the voltage a while ago was 0.5 amperes, so meaning to say this is charging. As soon as the current drops to zero, this cordless battery of my cordless screwdriver, okay, will be charged already. That was 0.5 something a while ago. And like what I said, when this current, okay, will become zero, this is now fully charged. And that's the time we shut off the charger. This is a heavy duty charging thing, right? You see this transformer here? The current that it could give will be very big. I just utilize two terminals to bring out a certain voltage and I cover the other things. So this is actually got so many extra voltages in which we could use. But I assembled this one. I just bring out the two terminals that I would like, so I could vary the voltage output of this one here. That's the rheostat in which to vary the voltage. And to indicate that the voltage is alive at the secondary, I got an LED here. So right now, this is 0.370. And that's it. I will come back after 15 minutes maybe. And let's try to measure the voltage of this. And I will try to operate my cordless drill if it works. A while ago, I measured the voltage is around 10.6. It could not operate this one. It just operate it intermittently. But if you're doing a power thing, this will not rotate. So better yet, we charge this one to around 12 volts plus, then we'll try to use this cordless drill. Good evening from Los Angeles. This is Professor David J. De Los Reyes. Okay, that's a current monitor. This is the cordless drill battery which are being charged, and this is our charger now. It's in a heavy duty one. Even 12 volt batteries for what you call this solar thing, it could this one could actually charge it. Good evening from Los Angeles. This is Professor David J. De Los Reyes.